Finding and evaluating inverse functions. Once we have a one-to-one function, we can evaluate its inverse at specific inverse function inputs or construct a complete representation of the inverse function in many cases. Inverting tabular functions. Suppose we want to find the inverse of a function represented in table form. Remember that the domain of a function is the range of the inverse, and the range of the function is the domain of the inverse. So we need to interchange the domain and range. Each row or column of inputs becomes the row or column of outputs for the inverse function. Similarly, each row or column of outputs becomes the row or column of inputs for the inverse function. So for example 5, we're interpreting the inverse of a tabular function. A function f of t is given in table 3, showing distance in miles that a car has traveled in t minutes. We want to find and interpret f inverse of 70. So t minutes, 30, 50, 70, 90 is the input. F of t, the miles, is the output. So we get 20 miles in 30 minutes, 40 miles in 50 minutes, 60 miles in 70 minutes, and 70 miles in 90 minutes. Now the inverse function takes an output of f and returns an input for f. So in the expression f inverse of 70, 70 is an output value of the original function, representing 70 miles. The inverse will return the corresponding input of the original function f, 90 minutes. So f inverse of 70 is then equal to 90. So the interpretation of this is that to drive 70 miles, it took 90 minutes. Alternatively, recall that the definition of the inverse was that if f of a is equal to b, then f inverse of b equals a. By this definition, if we are given f inverse of 70 equal to a, then we are looking for a value a so that f of a is equal to 70. So in this case, we are looking for a t so that f of t is equal to 70, which is then t is equal to 90.